Hello, everyone. So before we start writing our contract, it's very good to know what we want to do. And that is why this mind map is very important. This is a bounty protocol where someone can place a bounty on something they want others to solve for them. Maybe a car is stolen and you want to put a bounty that anyone that finds the car will get this amount of money and any other promise you want to make. So we have the bounty placer, we have the problem solver, that is whoever solves the bounty or does what you want them to do. Then this is the platform. This is the platform where you can submit the proof of what you have solved, as in the bounty. Then the platform will confirm it. After confirming it, will award the bounty to whoever solves the issue. Then we want the bounty to be in either USDC or ETH. Then the invariant should be the fact that funds should not be stored in the contract. What are the functions you think we need? Well, I think we need a function to submit proof, function to create bounty, function to accept or reject, to pay, and we should have one function. Maybe we should make it an internal function to refund users in case any payment fails and other abnormalities. Now that we have a very good grasp of it, I want to also point out that we plan to deploy this on linear because I'm building this contract to participate in the build on linear ongoing marathon. So we are deploying this on linear. And right now I'll be building the protocol and also explain as I go. So you also understand what I'm doing and also follow along. I'll definitely encourage you to code along with me so this can be more real and you get what I'm trying to teach very faster. You also improve and become better as a Solidity smart contract engineer. Without much ado, let's start. Of course, you write your pragma. That's the way you start contracts. And let's name it bounty protocol. So we'll need address public platform. This is the platform. Address public benefactor. Or you can this is simply the person who is placing the bounty. Or we can call it bounty placer. Let's call it bounty placer. Address public solver. This is whoever solves the bounty or whoever provides the solution. Right now, I'll go ahead to simply create a couple of state variables we'll need along the line. Every problem listed should have an ID. So we know this is a bounty that's A place or B place or C place, and it will be easier to identify. Then each bounty should have a description. Maybe you want someone to fix an abnormality in your website, or you simply want them to do anything. Then we need the amount for the bounty. By using the word bounty, we don't need to put amount because that's definitely what bounty mean in this context. This bool variable is to show whether something is verified or not. And as we go along, you kind of see how we use it. Right now, we need to probably create a modifier for what the platform can only call in terms of function. So let's say modifier only platform. Let's put the block first. Then let's require that msg.zender is equal to platform. Then error message. All right, we have that storage. What else do we need? We should configure a couple of things in the constructor. So let's make the platform the message does sender, meaning the platform with the deployment address. All right. What are the functions we need? Let's list them out before we start. So we'll be definite about what we want to do. We also need for verification, verify proof. Ideally, something related to ZK should have been the best thing for this verification, but we want to keep this not too high level and ZK build. Page solver in A. What else do we need? Yeah, we need to create a function for refund. So let's start with the placing of bounty. Let's start with the placing of bounty. Holy Ghost, why now? What are the variables we'll need? Let's get into this and say to U256 problem ID, comma, description. What else will we need? Bounty, yeah. It should be part of the parameters. Okay, string should be stored in memory or call data. Yeah, fix that. Then the main function. Remember, we've created a state variable here as problem ID. So we will simply assign it or define it. It's assigned to problem ID. Proof is assigned to proof. No, description rather. Bounty assigned to bounty. All right, let's come back to this. Then go to the submit solution. And we'll need a couple of things. Let's assign them. So proof assigned to proof. Solver is assigned to solver. So in this function, anyone who is able to solve the issue or solve the problem will submit the proof of the solution with this function. As you can see, it's in string, meaning it can be in text or maybe even a link to something else. Verify. This should only be callable by the main platform. You can use our other modifier here, only platform. Then say the address of the solver. Then what else do we need? Verification. Verified is true. Okay, maybe we shouldn't include the address of the solver here since it's simply verification. Then we can if we want to. So we can say address solver. Smart contract development is more about design thinking and building a contract the way you want it to function and not exactly mechanical. So let's try to pay the whoever wins the bounty. Let's come here and say we need a couple of state variables we identified earlier. Let's just use this. Let's make a call. Assemble successful bounty. No, is what's the target? The target is the solver. So solver dot call value. What's the value? The value is the bounty amount. Require successful bounty. This is for error handling. If you are not aware, error payment unsuccessful. But we need to think of something. What if the bounty amount is maybe 6 ether? Then whoever is paying puts probably 10 ether and there's excess. We should have something to checkmate that and send the excess back to the caller. So let's do that with the refund function. Then let's make it internal. Bool sense. We want MSD to sender, whoever is making the payment, that's the MSD to sender. So we want the refund to go back to that very entity. Dot call. What will be the value of what will be the refund? That should be the difference between the amount the person paid and what should be the amount of the bounty. Let's do a quick maths and say you're in 256, remaining money is assigned to MSD of value minus bounty amount. In that case, you're in 256, you have to create it, bounty amount. So the value should be remaining money. Require cents or payment on successful. Okay, let's read the message. I think it's okay. We didn't put this. That solves it. Then after this, we can put the since the internal function, we should add an underscore here. Best practices. So refund excess down the amounts. Oh, you know what? I think this is better. If we don't really need to use this as an internal function. We can simply call a for if and have a way. So I think we can do it this way and create a condition. If MSG value is greater than boundary amounts, then make this call. Let's create this here. I think this should work. Clean up a bit. All right, we still have work to do. We need to create events. We need to emit events to communicate properly with the front end. And to simply do that, let's start with the first function. Emit. No. List boundary. What are the things we want? MSG.sender. Then problem ID. Description. What else do we need to get? Yeah, the boundary. Let's go to create a corresponding event. Let's copy this and modify it throughout our code. This will be proof. So we need a boundary. Proof should be string. Good. We need the same for verify. We only need the problem ID here. Verify boundary. What else? The pay solver in ETH function. Okay, which one can get the job done faster? It solves it. Okay, it's outside of the function. We have all our events. Then we need to put a couple of error handling mechanism just for proper code quality. Particularly in terms of security, I think we need to focus more on the pay solver in ETH function. So at least let's put the fact that the amount shouldn't be zero. Then the amount shouldn't be zero. Then the address of the solver shouldn't be zero. That's the error here. Maybe let's not use a sign. Let's use equal. Yeah. Then if amount is less than zero, revert pay amount. Okay. Once again, let's go over our code and see what we've written so far. So created state variables, our modifier, our errors, our events, constructor configuration. We declared the function of placing bounties, then to submit solutions. And this is the function that the platform can use to verify that a solution submitted for a bounty is actually quality or is true or it solves the problem indeed. What else? Yes, this is the main function for paying whoever solves problems or fix things. Right now, we can go ahead to test. So simply come here and compile. Set this to inject a MetaMask, and we want to particularly use linear. Before we go ahead to test, let's drop by Chainlink to get some linear Sepolia ETH faucets. Apparently, it is the case that Remix has a glitch. So let's simply pop over to VS Code and try to deploy our contracts. So I pasted the code right into VS Code using Foundry and I've deployed it. Let's try to check up this transaction hash on the Explorer to see if the transaction was really deployed. We pasted the hash into the Explorer and now you can see this was deployed 5 minutes ago and every other details you might need. So this shows that we've successfully deployed the contract to the linear Sepolia blockchain. And do let me know if you would like to see the Foundry test for this contract.